I chose to present on publishing a command line tool to NPM. First, I'll give you guys a quick overview of popular libraries you can use. Then we'll go through a video walkthrough of our own CLI tool called Jasmine Spec Builder. And then I'll cover common requirements for publishing more complex packages to NPM. Yargs and Commander are two of the most popular libraries for parsing user input. They share a lot of the same features, but they do have their differences. For instance, Yargs is pirate themed, and the developer can also use types to check for invalid user input. Also, Yargs is in first place in terms of downloads, but is not too far ahead of Commander. Commander, on the other hand, can route commands to functions, which can definitely clean up your code. Commander has the largest active community on GitHub based on stars, but at the same time, we never really know why people click the star button. While Yargs and Commander are great for parsing user input, they still do not add any interactivity to your app. So this is where Inquirer and Yargs Interactive can come into play. A lot of the time when your app becomes more complex, you cannot set default values for certain values. For instance, a user may need to input their password or other sensitive information. This is where these libraries can help to prompt the user questions to set these values. Now on to styling. Chalk is a very popular library for adding more color to the terminal output. The developer can change the color for warning, success, or error messages. They can also bold, dim, and underline text, as well as create reusable styles like you see in the code snippet below. Aura is just a simple terminal spinner, but it does have a variety of spinners that you can use, instead of making one from scratch. Our ultimate goal of this video walkthrough is to build an NPM package called Jasmine Spec Builder. In short, it is a command line tool to build and update Jasmine spec files. You can generate a spec file from scratch or update an existing files providers, or in other words, stubs. Also, you have the option to utilize a master service stub to initialize service stubs for each unit test, and I provided additional information below on how to utilize this feature. Here's the app in action. I'm about to insert the build command in order to generate a new spec file based on the app component. Success. All right, let's see what was generated. All of the stubs were generated based on the services that were injected into the components constructor. Also, I used the file system of the user in order to generate the imports with the correct relative paths. Now let's update the spec file to use the master service stub. Success. All right. So now you can see that the spec file was transformed into using this master service stub. Now let's build this CLI from scratch. I don't want you guys to pay attention to the functionality behind generating and updating these spec files. Instead, I think it's more important to focus on how we set up our package.json file, and then we'll walk through how to set up our entry file. So the required fields in package.json include the name field, the version, which you want to start at 1.0.0, and then the bin field. The bin field acts a lot like the main field that you'll typically see in a package.json, but bin is used for executable files, while the main field is used when your application is being accessed through a require statement or an import statement. So we set bin equal to an object, with our custom command as the key. This makes it so that the user does not have to use the command of node and then the entry file in the command line. They can use JSB instead. The value is set to our entry file. The reason why index.js is inside of dist is because I happen to build this application using TypeScript. Eventually, the code will be transpiled into the dist directory, where the code will be executed. In terms of optional fields, we have the description field, which is indexed by search tools such as NPM search. Also, we have the keywords field. We can give a list of all the different keywords that define what a project is all about. This also helps in just making our application more easy to find on the registry. Then we have the author field and the license field. I chose to set my license to MIT, considering MIT is one of the most flexible licenses, and I can share my work with others with the least amount of constraints. Next, we have the files field, which I didn't happen to use in this project, but this is a field where we can whitelist all of the files that we want to push up to NPM. Instead, I used a .npm ignore, and I'll go through that later. And then we have the pre-published script. This script will be run automatically right after the user or the developer types in npm publish. You can set up a script to run tests here or build your code here. I did not happen to do this though. Now that the rest of our project has magically been built, you'll notice on line 35 that I installed yargs as our parsing library. Now let's head over to index.ts to set up our entry file using yargs. The first thing I'd like you guys to notice is line 1. This line represents a shebang. It tells the program loader which interpreter to use to scan the rest of our program. In our case, we want Node to scan the rest of our application. The shebang is mandatory in Unix-like systems, while Windows identifies the interpreter through file extensions. Next, I imported yargs as argv, and you'll notice that yargs uses a chain of methods. The first basic and important method is the command method. I can specify the name of the command as the first argument, as you can see on lines 7 and 5, considering we want to be able to update or build our spec file. And then I can provide the command with a description as the second argument, which will actually show up in the help dialog if the user were to type in JSB, like we specified in the bin object in the package JSON, -help, or -h, considering we made an alias for the help method. Next, you'll notice we chained example methods after the commands. These examples will also show up in the help dialog. Finally, we have the option methods. We can specify whether or not we want these options to be mandatory. On line 11, I use a demand option key and set the value equal to true or false. We can also provide the options with aliases. We can specify the number of arguments we're expecting. We can specify the description. This will show up in the help dialog, along with the data type we're expecting the user to type in. Lastly, we have the demand command method. As the first argument, we want to specify the least number of commands we're expecting. If the user does not meet this requirement, the console will error out and will tell the user that they need to insert more commands. Let's test out these commands in another application to see if they work. Below in the terminal, I'm in a child application to try to test my app against. Let's run a command with the file option. Uh-oh, the JSB command was not found. This is because our Jasmine spec builder package is not global. We don't need to make this global in order for it to work though. A very helpful NPM command that I discovered along the way was NPM link. What NPM link does is it creates a symlink in the global folder that's pointed towards your local package. So let's run NPM link. Let's make sure we're in the right directory. Yes, we are. Let's run NPM link. Now let's try it out again. Looks like it was recognized. However, we haven't attached these commands to any functions, so nothing's going to happen. But let's test out the help menu. Okay, as you can see, all of the descriptions that we added as second arguments to these methods and the examples are included in the documentation. Another important method is the check method, specified on line 55. This method will ensure that the input that the user provided is something we can work with. If the callback within this method returns true, we're good to go. However, if this callback returns false, a falsity value, or throws an error, we're not good to go. And we need to tell the user how they can fix their input to actually use our application. Something you may be wondering is how do we actually extract the arguments that yargs parsed for us? It's pretty simple. On line 44, you'll notice that I declared a variable and set it equal to the chain of methods. I console.log down here and ran JSB update file app.component.ts. You can see that the args outputted the update command that was used, along with the file option, which is mandatory, along with the file name. Now we can actually start our application up with the arguments that were provided. So here's the start application function. I'm just going to run you through one possible path. So if the build command was used, this application does what it needs to do to generate the new file. But the important part is that once this target file was created, I'm now writing to the file, to their file system. If everything is a success, I console.log to them that their file has been built. I could have used chalk here to brighten up the terminal. Let's get this thing published. If you don't already have an account on NPM, you can click the sign up button on the top right. However, it's pretty self-explanatory, so we'll move on. Once you do have an account, you can log in using the NPM login command. You'll also need to enter your credentials. This step is necessary in order to access the NPM publishing commands. And we're in. Another thing worth mentioning is my use of the NPM ignore file. I could have used the files field in package.json to whitelist certain files up to NPM. However, I chose to blacklist them here. NPM can also work with an a git ignore file. But in my case, I wanted to use two different sets of blacklisted files to push up to NPM and GitHub. So if you do have an NPM ignore file, NPM will not pay attention to the git ignore. Before we get into the actual publishing, we will need to talk about semantic versioning. So the far left digit under the version is a major update. It means that there's a new feature that was added and it's not backwards compatible. The middle digit is a minor update. A new feature was added and it is backwards compatible. The far right digit represents a patch. It's typically a bug fix and it's backwards compatible. So we can actually update the version using npm version commands. We can either use npm version major, minor, or patch. I actually want to patch this app right now because I did make a bug fix in the last couple of days that I'd like to push up to npm. So as you can see, the package.json version was automatically updated. Now let's publish using the npm publish command and see what's going on here. Takes a little time, but as we can see, Jasmine Spec Builder has been updated to 1.0.7. And if I'm lucky, an email confirmation will pop up on the top right, but sometimes it takes a little longer. There it goes. The video walkthrough hit the basics. However, there are more common requirements for more complex packages. These may include running tests before every publish, creating a git tag using semantic versioning, pushing your package up to GitHub as well as NPM, and creating release notes for every update. All of this may be annoying to do separately, so there are tools out there like NP to do all of this in one swoop. A couple other things worth mentioning that I did not cover are scoped packages and experimental releases. Thank you so much for listening, and here are my sources.